Every day, the future's getting closer.
Welcome to Master the NEC, where we talk about the National Electrical Code and all things electrically related. My name is Paul Abernathy, your host, and welcome to today's podcast. Well, hello, everybody. Welcome to Master the NEC, where we talk about the National Electrical Code and all things electrically related. My name is Paul Abernathy, your host today, and welcome to part 4 of a multi-part series dealing with box fill basics. Now, if you've listened to the previous episodes, you know that in part 1 and part 2, we pretty much wrapped up how to do the calculations for box fill and dealt with all those things and conduit bodies and whatnot. And we even moved into part 3. And in part 3, we talked about securing to the boxes and how to protect the conductors that enter boxes. So we've kind of moved beyond just box fill, but even though we're leaving it box fill because we started out there and we're ultimately going to end up in things to do raceway calculations for pull boxes, angle pulls, U-pulls, or whatever in 314.28. So we're kind of moving our way from there all the way up to end on that when it comes to the box fill series. And so we're kind of working our way through it. And so today's episode, we're going to talk about a couple of things that deal with raceways that have to transition between, they're called surface extensions from boxes that are designed in the wall for a flush type cover, but now you need to transition to a surface mounted raceway. And we'll talk about different supports for the boxes, because we spend a lot of time doing box fill, but we spend less time digging into the minimum requirements for like internal depth of boxes and the supporting requirements of these boxes, how you mount them boxes, because usually they come with nails and all this kind of stuff, but we want to kind of cover all those things and kind of give you a better understanding of it as part of the overall picture for box fill. So it's not just about how many wires I can put in a box, okay? It's a little more than that, and so we want to kind of dabble in that. So hopefully you've gone back and you listened to part 1 and part 2 and part 3 prior to this. Now, these episodes do get pretty long, and I don't break them down into 10-minute segments. People say, why don't you do that? I just don't have the ability to do that because once I get started, I don't want to lose topic. So the easiest way to do that is you to do that. Listen to the podcast, whether it's on our YouTube channel or Spreaker or from our website. When you listen to as long as you want to listen, pause it. And what you do is write down the timestamp of when you paused. And then come back later and simply fast forward and scroll over to where it starts again and just continue to listen. That way you can listen at your own leisure, whatever parts you want to listen to, and break it up however you want to break it up. Because I'm not going to attempt to do that. I'm going to do that for videos, start making the videos a little bit shorter to get to the point. But when I do podcasts, look, it's just a rambling, educational podcast. And I have to spend a lot of time being repetitious because I need to paint that mental picture. And it's very hard to do that on a podcast. So one thing I'm known for is to give you as much detail verbally that tries to paint you a picture in your mind so that you can follow along. And sometimes I have to do that and drag it out because I need to make sure that I feel that you're with me. And that's why I do it. Okay? So now, let's go on. Now, we've covered everything with box fill and boxes and conductors being protected as they enter boxes. We dabble in all that. Now let's talk about, well, what if I have that box in the wall and I've got an EMT running down the surface of the wall. Maybe it's drywall, gypsum, or whatever board. And now the wiring's inside the box that's in the wall, but now I need to transition out. Maybe there's a splice in that box, and I need to get out now into the surface extension, or whatever the wiring method it be on the surface of the wall. Well, we have an allowance in 314.22 that deals with surface extensions. It says surface extensions shall be made, so it's a mandatory requirement, not permissive. It says shall be made by mounting and mechanically securing an extension ring over the box. So if I got a box in the wall, if it's a 4-inch square box, then my box extension would be mirrored that 4-inch square box. It usually will have an open back on it. It will have the same cubic inch volume as the normal box in the wall would. So I'm going to get that additional volume. But that gets mechanically connected through the screws, the mounting screws typically for the cover or whatever device would be in there. That gets mounted into the box, and that holds it mechanically there. And it basically mirrors that box and extends it out beyond the surface of whatever the gypsum, drywall, whatever it is. Okay. And so once that's in place, then typically you'll have knockouts on the side of it, and that's what you can bring your surface extension into it, your raceway, EMT tubing, whatever it is, into that surface extension. The code says a surface extension shall be made by mounting or mechanically securing an extension ring over the box, and that's what you're doing. It also reminds you that the equipment grounding shall be in accordance with Part 6 of Article 250. So the equipment grounding, where it's required, you're still required to meet all of the requirements for whatever device is terminated on that box. All of the requirements that are normally required in Part 6 of Article 250 for the equipment grounding conductor and what have you are still going to apply. Don't think that anything's different. Okay, nothing different in that application. So keep that in mind. All right. Now there is an exception to this rule that says, well, you know what? There is an occasion where we're allowing you to go from the actual, let's say, a cover plate that can extend or from that box. And we've seen it. You've seen before a 4-inch square box with a flat cover on it that you actually have a 90-degree fitting that might come off of that box to, let's say, an FLMC, or flexible metal conduit, or something. And you're thinking, well, wait a minute, the general rule says I had to do an extension, but why is this allowed? Well, there is an exception to the rule, but you have to follow the exception. So the general rule is that you would have to have an extension ring to clear that out and be above the surface. But here's what the exception says. It says, a surface extension shall be permitted, so it's permissive, to be made from the cover of a box where the cover is designed so it is unlikely to fall off or be removed if its securing means become loose. So if the screws come loose or whatnot, so typically what happens is there'll be screws or whatever that make it so that there's no real means that even if the screws come loose, that cover can come off. Okay, so if that's the case, then I have this permission to allow me to extend from the cover. Now, it goes on to say, look, the wiring method that's going to allow me this extension, it says the wiring method shall be flexible for an approved length that permits removal of the cover and provides access to the box interior, and shall be arranged so that any grounding continuity is independent of the connection between the box and the cover. Okay, so if I had to remove it, so what are we talking about? Well, I have to arrange this. Well, first let's talk first. Could I go with an EMT to it and come off of it and have that EMT secured like it's supposed to be against the wall? Then I couldn't remove the cover unless I remove the straps on the EMT. So that's a no-no. So it's got to be some kind of flexible method, wiring method like FMC, LFMC, or LFNC that actually affords me this flexibility. It also has to be a way that when I do remove it, that it's going to have a link that's going to allow me to remove that cover so that I do have access to those interior conductors. Okay. Remember what we talked about in episode 3 extensively. In fact, I went into it in nausea. About having free conductors. So we have to, there's a reason why we have those free conductors space. And we need to be able to get those out so that we can get work in that box if we need to. But we need that flexibility to do so. The other key aspect here is that when we do remove the cover, it has to be arranged so that any grounding continuity is actually independent of the connection between the box and the cover. So what usually takes place is that we will have an equipment grounding conductor that's run with it as well, that runs through that flexible method into the box to make that connection, so that you do have, once it's removed, you do have this mechanism that allows that connection. So, but anyway, that's the general rule we've found. So, long story short, can we mount to this surface? Now, I see this mostly in 4-inch square boxes with the metal covers that have the knockout in the middle of it. Obviously, the knockout's there for a reason. But they also are designed in a way that when they're mounted to the box, they're not going to come loose. But even if they do come loose, they don't mechanically fall away. They usually are designed in a way to have the hooks so it can't fall off. But it has to be a concept of how it's connected in order to make sure the independent connection between the box and the cover is maintained for that grounding continuity. And there are plenty of covers and things that are designed for that application. Okay, so just keep that in mind. All right, we will cover that in more detail in our grounding series, but we just want to show you the allowance for what we're doing here. Okay. All right, so that's what we're dealing with, and that's how the exception applies. All right. Let's see. Let's move on to what seems to be the most important topic: is supports. Oh, I should also add, just for clarity too, that with that last part about the grounding, because I serve on that co-panel, what we want to remind you is that the integrity of the grounding between, let's say, a raceway that's connected to it, whether it's FMC or whatever it is, or whatever's being done, whatever connects to the surface of it, the integrity can't be solely dependent on the cover and its intimate connection with the box. That's all it's saying. That's all it's really saying. So typically with FLMC and things like that, you're going to run an equipment grounding conductor through anyway. So it's to the circuit itself. It's not relying on that cover to maintain the integrity. Say if you bond the box and then you mount the cover to the box, so the box is bonded to the box, to the cover is bonded to the box. That way it's grounded. But yet if it comes loose, the integrity of the system can't be dependent that cover needed to be connected to the actual box. So usually the circuit's going to have its own application where it's got an equipment grounded conductor running through it. If you're doing an application where the actual raceway itself or whatever the method was, maybe it's FMC of a smaller style under 250.118 could be used as an equipment grounded conductor, that it's not hinging on that cover. Okay? That's what it's trying to say. You might have to have a separate equipment grounding conductor run through to maintain the integrity even if that cover comes loose. So the cover can't be the sole means for this application if you're going to do this type of extension. That's all it's talking about. Okay? All right. So let's talk about supports. 314.23, huge topic. It goes from A to H. Whether we talk about all of them, I'll determine that as we move forward. But we'll kind of look at each one of them and kind of go from there. So what is 314.23? Supports. We're talking about the box because we're in 314. It says, enclosures within the scope of this article, okay, shall be supported in accordance with one or more of the provisions of 314.23A through H. One or more. So I could have more than one, if I wanted. But I got to at least meet one of the provisions here. Okay. Ultimately, I might, based on the listing of the box, have a requirement to have more than one application. But let's kind of follow through and see what we're talking about. Very first one, A, surface mounting. So I'm going to mount something on the surface. It says an enclosure mounted on a building or other surface. Again, when you say building or other surface, it could be mounting on, let's say, something that's a temp pole or whatever it is. It says mounting on the building or other surface shall be rigidly and securely fastened in place. If the surface does not provide rigid or secure support, additional support in accordance with other provisions of this section shall be provided. Okay, so you're going to securely mount it, but we have other provisions that you're going to see in B, C, D, whatever, that shall be applied in order to achieve the goal. And what is the goal? To surface mount it rigidly and securely in place. That's the goal. Okay. The other thing I will remind you that if I'm a manufacturer and I put 3 mounting holes in an enclosure, I'm going to expect you to use those mounting holes. I routinely see it has 3 holes in the back of a disconnect, for example, and they'll use the 2 holes like a pull-out disconnect. Simple pull-out. 60 amp pull-out disconnect. You have 2 holes at the bottom, a top, and 1 at the bottom. Routinely, I see them use the 2 holes, and it secures it, but there's 3 mounting holes there. The manufacturer gave you 3 holes. Me, I want it to be securely and rigidly fastened to the surface. Again, open to interpretation, but if I've got 3 mounting holes there, I'm using them. Okay? If I put a panel in and I've got 4 holes to mount that panel, I'm not going to use one at the top on one side and one at the bottom on the other side. I'm going to use all 4 holes. Again, you can interpret that how you want. Hope your inspector's rigidly securing it and rigidly interpreting it and deal with what you got to deal with. But if I'm mounting it, I'm going to use the mounting holes that they gave me. Okay, that's my little thing. If you want to try to do it with 2 and say that's good enough, trust me. Last thing, I've seen plenty of boxes and enclosures and whatnot come off the wall because they weren't secured properly or didn't use all the available securing on it. And the last thing I want, I'd rather have somebody call me if it looks like it's coming off and I still got 2 or 3 in there, that I can come and shoot one more in, longer screw or something, and fix it, than to have the whole thing pull off. Okay, a lot of cases, the raceways and the conductors are putting a lot of tension as they come into these boxes. And so, I want to make sure it's secure. Okay? Not everybody knows how to do box offsets and whatnot right, and all kinds of things with the raceway. And so it could put tension on the box. Who knows? So I want to make sure I'm doing it right. Okay? So that's my little soapbox. All right, so we need to do that. It's got to be rigid and securely fastened. Who determines that? Well, common sense probably does. But I can tell you right now, if I got 4 holes, I'm using them. All right, next. B is structural mounting. It says an enclosure supported from a structural member or from grade shall be rigidly supported either directly or by using a metal, polymeric, or wood brace. Okay? All right, so that's pretty simple. So it's saying, okay, well, I'm going to give you some items here, but these items, whether it's nails or screws or braces, they're going to have to either connect to metal, which like wood framing members or metal side or of a building or whatever it is. And that wouldn't matter whether or not it's to the building structural material or from something that emerges from grade. Let's say you're creating a post with a board on it to mount boxes on it for temporary or whatever you're doing. As it comes up, maybe mobile home pad or whatever, and you got something coming up, a framing member, it's made out of wood coming from or whatever. All it's saying here is, okay, it needs to be rigidly supported by metal, polymeric, plastic, or wood bracing. Okay, that are my choices. Okay, now to that material, you have some choices here. We have nails and screws, and then we have braces. Now, where it says nails, and we're in B1 now, so we know the material that we have to mount to. Now we're going to see the type of methods that we can use. So nails and screws were used, again, as a fastening means, shall secure boxes by using brackets on the outside of the enclosure. Okay, so that's typically the ones you see that got the little brackets on the side, like the nails or the screws that actually screw into the outside of the bracket, or by using mounting holes in the back or in a single side of the enclosure. Okay, so they also make the ones, like I said, where the 4-inch squares where you got the holes in the back and you're shooting the screws through the back. It says, or they shall pass through the interior within 1/4 of an inch of the back or ends of the enclosure. Okay? And it's very specific. Is they pass through the interior. They have to be within 1/4 of an inch of the back or ends of the enclosure. Okay? Now, what about these screws? Typically the nails go on the outside. That's usually not an issue. But what about screws? So screws shall not be permitted to pass through the box unless the exposed threads in the box are protected using approved means to avoid abrasion or conductor insulation. And then it goes on to say in the 17 change, it says mounting holes made in the field shall be approved. That allows you to cut your mounting holes in or drill them in the back of the box or whatnot. Still have to follow all the general rules, if you will, if you need to do that in the box. This does not allow you to take a plastic nail-up box, for example, and drill holes in the side of it so you can shoot sheetrock screws in the side, kind of like a cut-in box type of thing. They make boxes for that. They're listed for that. Not all boxes are listed, but there are some that are listed for specific applications. For years, I've seen people use floor boxes. They use a regular old nail-up box, cut off the ears, take out the nails, put the box down the right height, and then shoot sheetrock screws at an angle into the wood submember. And that's what they would do. Now, they make boxes that are designed for that, but not a regular nail-up box is not designed for that. Okay. Now, this is also saying that, you know what, you can put screws in it, but you need to do it so that none of those threads are exposed. Okay. And they have to be protected by some means. There are boxes that have screws that actually do. There's a lot of fan boxes that actually have screws that do go through the middle of the box. But usually they're sleeved through some kind of chamber or something that's going to not have those threads that are exposed to any of the conductor insulation, because screwing it in and out, whatnot, if any of the wires get near it, it could simply cut right through that insulating material and create a problem. Okay, so just things to think about. Most of the time the boxes have the nails on the outside or the screws that are going to go into the back of the box that you're not going to have any threads exposed. There are some, for example, like for fan boxes that have a long set of threaded screws that might go through. You just have to make sure that screws that do pass through, that you don't have any exposed threads in their nature. Okay, so so that's covering that one. Now, we move on to braces. Now, dealing with the metal braces in 314.23b2, because we talked about nails and screws, but what about braces? It says, metal braces shall be protected against corrosion and formed from metal that is not less than 0.020 inches in thickness, uncoated. Okay, so that's the pure thickness. Now, good news is if they are listed, the brackets are designed for that and all, that they're going to have zinc coating on them or whatnot. They're already going to be in place, and that's simply something you would just buy, and you don't have to overthink that. It says wood braces, if that's the choice. Wood braces shall have a cross section not less than a nominal 1 inch by 2 inches. It says wood braces in wet locations shall be treated for the conditions. Okay, so it's treated wood. Polymeric braces shall be identified as being suitable for the use. In other words, the environment, the temperatures that they can be subjected to. Wood, if it's treated, can go into really cold weather, whereas a polymeric brace, for example, will have a temperature limitation on it. They could crack or become brittle, and you have to keep those things in mind if you use that. So just keep those in mind, whatever choice you make. I can tell you, if it's a polymeric brace for a box, then there's a chance that it's already been evaluated. You need to look for that to see what conditions, thermal conditions it can be located in, or what condition of use it can be used in. Those are the type of things that you want to take into effect. Okay, so keep that in mind. I think the one that probably tricks up people the most is when you're using a wood brace. Let's say a brace between framing members, and you're going to mount a box on it. Most people don't realize that it has to be at least 1 inch by 2 inches. And so they will take a piece of furring strip or something and try to mount a box to it. It's just not going to work. So you have to meet those minimum requirements if you're going to use wood as a brace. The metal ones they make that go between joists or between framing members that are supports, they're going to meet all the requirements from that manufacturer and things like that. Usually they're going to be from a reputable manufacturer. And so all those type of things. So think about all those things. There are boxes, for example, that are designed, metal boxes, that actually have nails that you would actually nail through and actually go through the actual interior of the box. Okay? But they are located very close, and they're not more than 1/4 inch from the back or ends of the enclosure. Okay, so that's kind of what we're talking about with those as well. You nail them through, they're located near the back of the enclosure or the ends, okay, top or bottom end or however it is. So they're not going to be up into the middle of the box. They're going to be very close to the edges or the back, and that's what that's kind of talking about. There are plenty of those metal boxes that nails, that 16D or whatever they're called, nails will go right through the box and you nail it up. We usually use the plastic ones with the nails are on the outside of it, so it's not a big deal. But when using metal, then they many times are going to actually go through the back box. But those holes are located specifically not more than 1/4 inch from the back or the edge. Okay? So that's what we're covering for that. All right, next we'll move on to C, which is be a really quick one, which is mounting in a finished surface. It says, okay, so remember, we're talking about enclosures, boxes, whatnot, mounted in a finished surface. It says, an enclosure mounting in a finished surface shall be rigidly secured thereto by clamps, anchors, or fittings identified for the application. So if you're putting it in a wall, then if you buy the thing, it's probably going to have some type of clamping or anchoring system that's designed for it. Okay, if you're putting a box that's mounted in there. If I'm doing let's say a panel, for example, enclosure that's mounted in a finished surface, then it's usually going to have mounting holes on the side, and I'm going to have anchors or I'm going to have screws or whatnot in order to be able to make that connection into it, that type of thing. So just remember that if I'm mounting in a finished surface, an enclosure mounted in that finished surface, it's got to be rigidly mounted by clamp, anchor, or fittings that are identified for the purpose. Well, screws are an anchoring method that's identified for the purpose. Okay. One other great aspect of this, although we'll talk about floor boxes at some point, is that's a finished surface, and so the boxes are typically identified, listed for floor application, floor boxes, and they will have some kind of method, clamping, anchoring system that's incorporated into it that you have to take into account. So that's a good example of something like that. All right, the next one we'll talk about is D, which is suspended ceilings, drop ceilings, things like that. It says, an enclosure mounted to structural or supporting elements, which is the grid, of a suspended ceiling shall be not more than 100 cubic inches in size, and shall be securely fastened in place in accordance with either 314.23 D1 or D2. So we have a D1 or a D2. One thing to remember here is suspended. These are enclosures. Okay, we're not talking about the luminaires. This is enclosures. So for an enclosure mounted, when I say luminaires, I'm talking about let's say like a recess can. Okay, it's not what we're talking about. Remember the subject of the topic, boxes and things like that, enclosures. So where we're doing it, it's going to be mounted to that supporting element of a suspended ceiling. So this is mounting to it, that it can't have more than 100 cubic inches in size. Okay, first thing to remember. Now, when I'm doing it and it's not more than 100 cubic inches, how do I secure it to that framing member? Well, I have two options. I can use the framing members, and we'll talk about that. Or I can use independent support wires, and we'll talk about that. And that's going to send us back to a 300.11a provision that we're not probably going to talk about, but we'll reference you back to it, and I might say something about it. But we're going to give you these two methods to do these boxes. Now, the first one says framing members. It says, an enclosure shall be fastened to a framing member by mechanical means such as bolts, screws, or rivets, or by use of clips or other securing means identified for use with the type of ceiling framing member. Okay? It says, and enclosures employed. Whatever the enclosure is, it might have an attachment mechanism already built in that will connect into the framing member of that suspended ceiling grid. So that is your mechanical means to do that. So that might be built into it. In some cases, you might screw it, bolt it, or even rivet it to that method. Okay, so that's the ceiling framing member. It says the framing members shall be supported in an approved manner and securely fastened to each other and to the building structure. So if my framing system is going to support these boxes, then that framing system needs to be secured to the building structure. Many times it's connected by the frames, and at the ends they're riveted to the back or the side frame, and then all that's rigidly connected to the framing member. So again, the caveat to doing this method is that the framing members themselves shall be supported in an approved manner. Who approves that? AHJ. And securely fastened to each other and to the building structure. So each one of these members connect together. The overall assembly gets connected to the exterior frame that's connected to the actual building structure. If that's the case, then I could use that supported ceiling grid, that framing member, to be able to support my enclosure up to 100 cubic inches. Okay? That's what I could do with that. Now, what if I've got an optional method. Well, not an optional. I have another method, supporting wires. Now it says, this is D2 now. It says supporting wires. It says the installation shall comply with the provisions of 300.11a. I guess we got to go look at that, but let's keep on reading before we go look at 300.11a. It says, the enclosure shall be secured using identified methods to ceiling support wires, including any additional support wires installed for ceiling support. So what this means is, it's kind of redundant on our 300.11, is saying, look, I might have support for the actual grid, but they are different than the support that I would have to add to support these boxes or these enclosures. Okay? That's what it's saying. And 300.11a kind of gives it even more detail. So, in other words, you're not allowed to use the supports for the grid to actually support the box. But you could add a separate support for that box, and it has to comply with the provisions of 300.11a to be able to do that. That's basically what it's saying. Now, it also goes on to say that these support wires used for enclosure support shall be fastened at each end so as to be taut within the ceiling cavity. So if I have a box, so I get this question a lot, or I used to, and they'd say, look, I'm coming from the ceiling, and does that mean that box gets connected in a trapeze type of effect? And the answer is no. It has to be connected at both ends to support that box, and it has to be taut. Okay, so it has to be tight so that it doesn't swing around like a trapeze. Right? And that's what I'm going to secure. I'm using something like a Bat Wings. That's one brand that's made by Caddy. In order to secure that box rigidly in place, it doesn't swing around. That wire's taut. That is not the same wire that is used to hold up the grid. Okay? And that's what's so important about 300.11a. So we're going to go look at 300.11a now that we kind of know the context of what we're talking about. All right. In 300.11a, it simply says this. Securing in place. It says raceways, cable assemblies, boxes, cabinets, and fittings shall be securely fastened in place. And then, of course, you go into B, which is above suspended ceilings, and you'll go into item 1 and item 2, which is dealing with whether it's a non-fire rated ceiling or fire. But the whole premise of sending you back to 300.11a is to remind you that you can have that trapeze effect. The beauty of the guidance that we got over in 314 is to say, look, it's got to be taut in place. These boxes have to be secure inside of this area. And then to get into more detail, okay, then you get into all the aspects here in 300.11, B1 and B2 and whatnot. But all we wanted to do back in 314 was to kick ourselves back and say, hey, it's real important that you understand that these support wires have to be in place. They have to be taut. They have to be, and the requirements 300.11a says that the boxes have to be fastened in place rigidly. So these two kind of work together. Okay? That's just kind of what they're saying. They just kind of work together to make sure that box is secure. And it also goes the same way, although we're talking about boxes here. When you go back and look at that about 300.11a, and then you get into the other aspects for above suspended ceiling in B1 and B2, you're going to have the same principle because we don't want them swinging around. The integrity of the armor, the integrity of the installation, all is maintained by keeping it secure in place. We do not want to use the ceiling support for that. Now, there are some occasions you'll see back in 300.11 B1 and 2 where you might have a fire-rated assembly, whereas these supports are designed for that application, and they might allow you to connect something to it. But the general rule is you do not. Okay, so we don't want to go into the aspects of 300.11b1 and 2 on this episode. We're talking boxes that have to be rigidly supported, and you have to connect that support wire at both ends. That's what we want to take away from today's message. Okay, I'm glad we got that nailed out. All right, so now let's go on to E, and it says raceway supported enclosures without devices, luminaires, or lamp holders. So this is simply an enclosure that has raceways coming up, that is literally, that is what is doing the support of that enclosure. That is it. So what does the code say when we have that? Now remember, there's no devices in there. There's no luminaires on it. There's not even a lamp holder on it. Okay? And if you're asking me what a lamp holder is, that's like a keyless with a lamp in it, or we refer to as a bulb. That is a lamp holder. That doesn't necessarily mean it's a luminaire. And you can go back in the definitions and understand the difference of the two. But they are different. So it's important. Now, you could have something that is a luminaire that looks very much like a lamp holder, but there are two different dynamic pieces of equipment that you have to understand. All right. So anyway, so if I want to support a device box or an enclosure, a luminaire or a lamp holder, they cannot have those devices in this enclosure to be supported by a raceway support only. Now let's read it. It says an enclosure that does not contain any devices other than splicing devices. So obviously you can have wire nuts in there or wire bonding devices or whatever. It says also it does not support luminaires or lamp holders or other equipment, and is supported by entering raceways shall not exceed, again, we're going to see this familiar, 100 cubic inches in size. Okay? So, it is a raceway that is supporting an enclosure, and that enclosure is not more than 100 cubic inches in size, and it does not have devices in it, luminaires, or it doesn't even support any luminaire or lamp holder. Okay? So the raceway is supporting this enclosure. That's what it is. And it can't be larger than 100 cubic inches. Pretty simple, right? It says, it shall have, okay, so in order to do this, it shall have threaded entries or identified hubs. So in a lot of these cases, you will have these boxes, these FS boxes or whatever, that have a built-in hub that screw into it, okay? And so that's kind of what it's talking about, that are identified for this. So you have either the threaded entry or they have a built-in hub that goes into it. All right, now it says, it shall be supported by 2 or more conduits threaded wrench tight, not hand tight, wrench tight into the enclosure or the hub. Okay? Now, why is that significant for me and you if we're talking basics? Well, first things first. You notice that it said conduits? Conduits threaded, not EMT, which is not a conduit. That's a tubing. So it's talking about, so this is going to limit us to rigid or intermediate metal conduit only for these applications. Now, how many times do I go out and I see that people do this wrong? Now, we're going to look at an exception here in a minute, but they do this and they don't understand the minimum of 2 or more conduits threaded, and it says conduits, threaded wrench tight into the enclosure. Not into a connector that goes into the enclosure, but threaded directly into the enclosure or a hub. Okay? Now, it goes on to say, okay, now, once we've established that, it says each conduit shall be secured within 3 feet of the enclosure or within 18 inches of the enclosure if all conduit entries are on the same side. So if I'm within the same side or they go into the same side of, and you'll say come into the bottom, then as long as I secure it within 18 inches, okay, then I'm good. So 18 inches if they come into the same side, okay? All right, so we're covered in that aspect of it. All right? So our normal securing in the rules that we follow here, it says, again, each conduit shall be secured. We're talking securement of the conduit now. Remember, the box is designed to be rigidly secured, okay? But in this case, we have to, each conduit will be within 3 feet of the enclosure, okay? But there are occasions, like I said, where it might stick up above and you need to secure it. And so since it's coming in the same side, then the minimum we have to secure it within 18 inches as long as both conduit entries are on the same side. Okay, it's kind of like poking up out of the ground or coming up. Okay, and usually they will be in the same side of the box. Okay. If it's coming in left to right and it's not the same size, then we have to make sure that it's secured within 3 feet of the enclosure, which is our normal securing requirement for most of these type of conduits, okay, within so many feet of the box. That rule doesn't change. It's only when they come into the same side, and typically this replicates the supporting of the box basically in free air from those from those conduits coming in from the bottom. All right. Now let's look at the exception. What does the exception say? The exception says the following wiring methods shall be permitted to support a conduit body of any size. Okay, so this is talking about conduit body, not just the box. This is a conduit body because routinely we have conduit bodies that are kind of floating out there because of how they change direction. So we have to have an exception to this. And it says, the wiring methods shall be permitted to support a conduit body of any size, including a conduit body constructed with only one conduit entry. Okay, so whatever it is, you only have one conduit entry going into this conduit body. Maybe you're sealing the other end or whatnot, provided that the trade size of the conduit body is not larger than the largest trade size of the conduit or tubing. Okay? So very similar to what we said about the 3 foot for a box. So let me give you an example. Let's kind of cover this again. So if I have a box and it's in free air, let's just say it's hanging. We're not talking about one that's emerging from grade. Maybe a box is coming in from the left and to the right side. It's not the same side of a box. Then I can go all the way back to 3 feet and put a strap on that conduit as long as it's intermediate or rigid for the general rule for boxes because it's about the threading. The boxes tend to be a little bigger and that goes up to 100 cubic inches. So I can do that. If it enters into one side of that box, maybe say coming from the bottom, then that would be securing within 18 inches. But if I'm coming in from the left and the right, that box can be kind of suspended, if you will, in air, as long as I have a strap on those conduits within 3 feet of the box, which is normal. And that allows that box to kind of float there. And that happens all the time from up in the ceiling from, let's say, a truss to truss in a commercial building, and that's okay. Now, when it comes to the LBs, notice that rule only applied to conduits with threaded wrench-tight entries for boxes. With the LB, it's laxing it up a little bit. It's saying, okay, look, for the conduit body, and not just LBs, it could be LC, whatever, it's just a conduit body. For conduit bodies with a trade side that is not larger than the trade size of the raceway that's supplying it, so if it's got a knockout that's the side that into the conduit body is designed for a trade size 1 inch, and as long as that raceway doesn't exceed 1 inch, then that's the size for that conduit body. Then I can do the same thing for the conduit body. It can be suspended and not individually supported to anything. It just be in the air, if you will. And the thing about it is, now I'm opening it up to use other types of wiring methods, whereas the box was limited to conduits with threaded wrench-tight enclosures with hubs or the enclosure. Here it's saying, look, I'll let you use IMC, RMC. Hey, I'll even let you use PVC for this application. Reinforced thermosetting resin conduit, RTRC. I'll even let you use EMT when it comes to these conduit body. So I'm allowing you more wiring methods, but it only pertains to these conduit bodies because we do have these conduit bodies that kind of do float. There's no way to mount these. They're not designed with holes in them to drill and mount them. Okay? And so while I can have boxes suspended in the air, so can I have conduit bodies. But I get more options for the wiring methods for use with the conduit body. Now, one thing to keep in mind that the issue still applies. These have no devices, no luminaires, and no lamp holders involved in them. Nothing like that. It is simply being utilized for splices or as an access point. That's it. Now, that takes us to F. Now, F says, well, raceway supporting enclosures that do have luminaires or that do have devices or lamp holders that are going to be from that actual enclosure. Well, that's a different beast all in itself. So what do we have to do here? Well, it says this. It says an enclosure that contains a device, receptacle, switch, whatever, other than splicing devices, wire nuts, if you will, or supports a luminaire or a lamp holder or other equipment, and it's supported by entering raceways, shall not exceed 100 cubic inches. So we still have that 100 cubic inch limitation on these boxes that are being supported by raceway. It says, it shall have threaded entries or identified hubs. It shall be supported by 2 or more conduits threaded wrench tight into the enclosure or hubs. And then it goes on to say that each conduit shall be secured within 18 inches of the enclosure. Okay, so at this point, it really does not matter, okay, whether or not the application is mounted to something or the box or whatever. The box is not mounted. The key here, it's going to require that you're going to have this securing. That's going to take place. So we do have some exceptions here that we're going to look at and things like that. Okay, so don't get lost in what we're looking at. But that's the general rule. And we're going to have to secure each conduit within 18 inches of the enclosure. So this is an enclosure that does have devices, does have luminaires, does have lamp holders in it, doesn't exceed 100 cubic inches. It does have threaded entries. Okay. Now notice when we say that it has those threaded entries, that in this case, the raceways had to be secured within 18 inches of the enclosure. Then we get into some exceptions. And now let's kind of look at the exceptions. All right? All right, the very first exception, it says, exception number 1, rigid metal or intermediate metal conduit shall be permitted to support a conduit body of any size. We kind of went over this already. This is no different. A conduit body of any size, including a conduit body constructed with only one conduit entry, only one entry into it, provided that the trade size of the conduit body is not larger than the largest trade size of the conduit. In other words, that conduit body is designed to receive a trade size 1 conduit entry, and it's not larger than that. Okay, so they both match. So that's the exception that allows us to be able to do that. Okay, and that shall support it. So the only thing that differs here is that we're talking about if the actual conduit body happens to have a raceway supporting a conduit body that actually contains a luminaire or devices or other equipment must be rigidly supported by rigid metal or intermediate metal conduit, because that's basically what the rule is saying. And again, as long as that trade size does not exceed that of the conduit body, okay, it can't be larger than the largest trade size of the supporting raceway. So it's a trade size 1, conduit body receives a trade size 1, that's fine. Okay, could I do a reducing box, LB that reduces, or a conduit body that reduces down to 3/4 and use it on something like that? Maybe I'm using 3/4 raceway, a conduit, but I'm using a box. Then that would be if it's a 1-inch box opening, that would be a problem, because the trade size of the conduit body must not be larger than the largest trade size of the supporting raceway. So it's a 3/4. So you couldn't use that. So you can't go larger. Okay. It can't be larger than whatever the raceway is supporting. All right, so that's just, again, if you had it, and I haven't really ever seen an application where any conduit body contains any devices, luminaires, or lamp holders. So 1 is probably not the best application. Okay, so also, I guess the only conduit body not requiring to support raceways, I guess, is a conduit body constructed with only one conduit entry. If it only has one conduit entry, then that's where the exception will apply. It says, so the only conduit body not requiring 2 supports is a conduit body that has only one entry. Okay, and I'm not sure, I guess maybe you have one that just stops at the end or something, who knows. Anyway, that's what the rule is. Probably not as practical application. So now we get into the next one. So the exception number 2 says, okay, any unbroken length of rigid or intermediate metal conduit shall be permitted to support a box used for luminaires or lamp holders support, or to support a wiring enclosure that is an integral part of a luminaire. Okay, it's kind of a component that's built into it, or part of it. Okay, it says to support a wiring enclosure that, again, has an integral part of the luminaire and used in lieu of a box in accordance with 300.15b, where all the following conditions are met. So what are we talking about here? So look at the different conditions here that we've got to meet for this. All right, and this basically talks about one of the applications where I can actually have a luminaire, let's say, that's going to be supported by a raceway, and it actually goes to the end of the raceway, and this luminaire is being supported by a single conduit and all that. So we have to read all the rules in order to be able to apply this. Okay, so it's an unbroken length. That means it's kind of like maybe has a shepherd end on it or whatever, and it goes straight from the box all the way out to where the luminaire is or whatnot. So let's look at the rules here. Number one, a conduit is securely fastened at the point so that the length of conduit beyond the last point of conduit support does not exceed 3 feet. So let's say I had a building and I have a box at the top. I have a raceway that comes off, and at the end of that raceway we're going to have a luminaire. And that luminaire is going to be supported by this raceway. Okay? And that last point of securement is not more than 3 feet away from it. So where it goes into the luminaire as it works its way all the way around to, let's say, the side of the building. So this is kind of a light that's hanging off like for a sign display or what have you. So when we say 3 feet, we're not talking 3 feet as a crow flies. We're talking 3 feet of raceway, because that's what it's talking about. So you actually follow the raceway around, and so the conduit is doesn't exceed 3 feet from the last point of securement, okay? Or from the last conduit support, okay? So that's what we're doing. So that's the first caveat. So that would maybe cover where we had the junction box and we have one piece of raceway that's extending out over the edge of a roof or something like that. That might be. So that's the first caveat. And remember, it's an unbroken length of rigid or intermediate. That's what we're talking about here. And they're using it to support, let's say, a luminaire or some other device. Okay, there you go. That's the first one. The next caveat that says, okay, we have that unbroken conduit length before the last point of conduit support is 12 inches or greater, and that portion of the conduit is securely fastened at some point not less than 12 inches from its last point of support. Okay? So painting you a visual, we need to make sure that that piece of raceway is not just right there at the edge, and all that pressure, that teeter-totter pressure, if you will, from the luminaire is being transferred to this box. We need to have at least, as it comes from that last support back towards the box, I need to have at least 12 inches of conduit or greater, because it kind of gives that stability to be secured to the actual surface. Okay, and then not putting all that teeter-totter pressure on that box. Okay, so that's what we're dealing with there. Okay, and you're remembering what we're talking about here. We're talking about raceways that are actually supporting, in this case, the luminaire in our example. Okay, now we keep on. And so again, at that point, it has to be at least once from that last support that goes before you had that 3 feet out to the luminaire. Once you have that support at the edge, you have to have at least 12 inches or greater of the conduit that is actually from that last, before you get to that last support, you have at least 12 inches of the conduit. Okay? And it is securely fastened at some point not less than 12 inches from its last point of securement. Okay? So it's got to be at least more than 12 inches securement. Okay? And it can't be less than 12 inches from it. All right? If it was less than 12 inches, then it means you didn't have 12 inches of the required length or greater of the conduit. So that's kind of a no-brainer. All right? So you're painting this picture. We have a light that's hanging over the edge of a building that's maybe a sign light The luminaire is mounted to the raceway. It comes back to right when it gets to the edge of the building. You have that securement because you can't extend out more than 3 feet. You put that strap that raceway down. You have to go before that as you're continuing back to the junction box. You have to make sure you have at least 12 inches of raceway. Can't be less than that because you need to have that area to mount against the surface. So once you have that, okay, again, unbroken conduit. So the unbroken conduit before the last point of securement, it has to be at least 12 inches or greater. And that portion of the conduit is securely fastened not less than 12 inches from its last point of support. Okay? So once that's taken place, then you know that conduit is securely down to the surface. Okay? And it don't have this teeter-totter effect. It's not going to put undue stress on the connection to the box. Now, next one, it says, where accessible to unqualified persons. I guess anybody could get to it. It says the luminaire or lamp holder measured to its lowest point is at least 8 feet above grade. So it's got to be, to do this, it has to be at least 8 feet above grade. And it has to be at least 3 feet measured horizontally to the 8-foot elevation from any windows, doors, or porches, fire escapes, or similar locations. So it has to stick off if you want to do this, and it has to stick off far enough that it can't be reached if I open up a window or any fire escape or any porch or deck or whatever. If you're going to use this method, I think of it commercially. If I had some of these lights that extend off the building and the raceways or the conduits actually supporting the luminaire for like sign display lighting, and you want it to shine back onto the building, that it has to be in a way that you can't, it's got to be at least 8 foot high, and it can't be within 3 feet of anything like windows, fire escapes, decks, doors, whatever. Okay, similar things. You don't want to be able to reach it. Okay. Now, some people say, well, God, what if I want to change the bulb and a lamp and I don't want to have to, whatever. I'm just telling you, if you use this method, it's got to be out far enough that that's not going to be the case. All right. Next thing you have to meet is, it says the luminaire supported by the single conduit does not exceed 12 inches in any direction from the point of conduit entry. Okay, so that's the luminaire itself. Okay, does not. Okay, so the luminaire does not exceed 12 inches in any direction from the point of conduit entry. So you're kind of going to be limited into the size of the luminaires you can use. Most of these are simply just going to be, ends that shine down onto signs or whatnot like that, or some flood lighting type of situation. So they're not going to meet that, have a problem with that. But if it's being supported by that single conduit, again, this is the exception to the requirements for 2 conduits. This is your allowances for that 1 conduit to support this luminaire or device or whatever. So that's why we're dealing in the 1 conduit words. All right. Next, it says also the weight supported by any single conduit does not exceed 20 pounds. So you're going to have dimensional limitations on this luminaire. You're going to have weight dimensions on this luminaire to be able to use this single support. So that aspect of it as well. It goes on in the last one. It says at the luminaire or lamp holder's end, the conduit is threaded wrench tight into the box, conduit body, integral wiring enclosure, or identified hub. Now, most of these lamps, the luminaires that do this, they're designed to screw into the end, so they have a wiring compartment in the end, and that's where you're required to have intermediate or rigid, threaded, that way it screws into the end or into some hub, okay? But in this case, it requires that, okay? Now, it says where a box or conduit body is used for support, okay? So we have a box or conduit body that's on the end. It says the luminaire shall be secured directly to the box or conduit body or through a threaded conduit nipple not over 3 inches long. Okay, so some cases you'll have a box at the end, and your luminaire, based on how it's designed, will have a nipple that screws the luminaire onto the box rather than it screwed directly to the box. Other than screwing directly to the luminaire, that is the rigid conduit or intermediate conduit, you might have a box in there. And where you do have the box that does this, you got to make sure that if you're using a nipple in order to connect the luminaire onto it, that's not more than 3 inches long. Okay, so you still have all the rules that you have to meet. So these are the allowances for you to be able to support that enclosure that has a luminaire in it, or a device or a lamp holder in it. You got to meet all these caveats. And this typically is when you might, again, have a luminaire that's hanging off the side of a building that's maybe shining back onto the building. All right. And a lot of people do things like a shepherd hook. They bend their conduit in order to be able to do that and turn around, and then they screw you can buy them. Some of them, again, you mount a box on the end and then you have a nipple and that'll connect the luminaire onto it. Different types. Some of them even have the box that mounts to the end, and then the cover holds the lamps, if you will, like fluorescents to it. All these still apply if I'm going to use that raceway as a support to that box or that enclosure. Then you got to meet all these caveats. Okay? Wow, that was a lot of information. And if you didn't get confused in that, I don't know what else can. I'm probably going to be doing a video on this concept because it's very hard to gather all of this. So hopefully we will try to. All right, let's move on. Next, we're going to talk about enclosures in concrete or masonry. And that is G. It says, an enclosure supported by embedment shall be identified as suitably protected from corrosion and securely embedded in concrete or masonry. All right, so where I have that application and where those boxes are, they're usually going to be they're going to be identified as being able to be embedded in concrete or whatever. They're going to be zinc coated or they're whatever they are. They're going to be designed for that application. So that's going to be a no-brainer. So you're just looking for a box that's designed for that application. Okay. H, pendant boxes. Okay. So when I have pendant boxes, we have to meet the requirements here. So an enclosure supported by a pendant shall comply with 314.23 H1 or H2. Okay, so what are we talking about? H1, okay, flexible cord. It says, okay, so this is where we might have a box. So what we do is we have a box, and then we have a device box that's hanging down lower, and it's hanging down by a flexible cord. Okay, now, what does it say here? It says, a box shall be supported from a multi-conductor cord or cable in an approved manner that protects the conductor against strain, such as a strain relief connector threaded into the box or the hub. So if I have a box and it's a multi-conductor cord or cable is used for this application, then I want to have what's called strain relief on it. And that's going to be at the box that's hanging down lower from the cord, as well as up at the box that this cord is hanging from. Very common in industrial and commercial applications to get your receptacle hanging down to the location where you're going to do the work. And that is called, from a pendant box, and that is called a flexible cord connection. All right? So when you have that application, then we're going to need to be able to have the strain relief for that. Now, it also says H1 or H2. Now, what is H2? Conduit. Okay, H2 talks about a ceiling stem support system. That we're talking about H2. And here's what it says. A box supported, a box that's supporting lamp holders or luminaires or wiring enclosures within luminaires used in lieu of a box. Okay, so some of these have their own compartments in it. Okay, so these luminaires have their own space for making these connections and what have you. It says, shall be supported by rigid or intermediate metal conduit stems. That's the rule. Okay. Now, it says, for stems that are longer than 18 inches, because, typically, if they're sticking down and they're not more than 18 inches, then you're using rigid or intermediate. But what happens when I have the stems that are longer, that are going to come down further than 18 inches? If that's the case, this says the stems shall be connected to the wiring method with flexible fittings suitable for the location. Okay, so what are we talking about there when you think about those flexible fittings? Well, let's think of it this way. How many times have you seen those ceiling fans you put up that has the flexible end, the ball or whatever, that allows the fan to move left to right, whatever? Same concept. So once I get over 18 inches, less than 18 inches, then it would be kind of rigid. Once I get over 18 inches, up at the box where it's extending down, I have to have some ability to have flexibility so it can move. If there's something hits that lamp or that luminaire and it kind of moves a little bit, I can't be so rigid. It has to have some ability to flex. And so you have to think about that. So that has to be incorporated into the portion where the actual down rod, if you will, connects to the support at the box up at the ceiling or wherever it is, okay, for that conduit stem that's coming down, okay? So you definitely have to keep that in mind for that flexibility when that's the case if you're using a conduit. You're going to need that flexing, okay? Now, what does it say? All right, that's up at the other end where it connects to the box. But when it comes to the luminaire end, it says that the luminaire end, the conduit, shall be threaded wrench tight into the box, the wiring closure, or identified hub. Then when we say wiring closures, some of these metal halides, these big ones, they have a mechanism in them for this to thread right into it, and there's a space for the wiring and terminations and all this type of stuff, or to get in there. That is all built into it. Okay, so keep that in mind. But if you're over 18 inches down and you're using a conduit from the box coming down, then theoretically that is a raceway supported luminaire onto that raceway, and it is a single raceway. Then if it's over 18 inches, it has the ability to have up at the point where it connects to the box that's supporting the raceway, or the conduit in this case, then you want to make sure that it is flexible, that it allows it to move a little bit, okay? Now, another reason I'm kind of using these terms interchangeably is that tubing is also a raceway, but it's not a conduit. And so when I'm talking conduit, a raceway, and then I correct myself and say conduit, it's because I'm being very specific. In this case, these down tubes or these supporting stems that are of conduits are rigid and intermediate because they're required to thread at the luminaire end or the box end that's down low where the luminaire connects to. That has to screw into it, and it has to be wrench tight. Okay, so you have to take a wrench to it. It's not hand tight. Okay? All right, so that's the concept of that. Now, it goes on to say, look, whereas supported by only a single conduit, and that's what the whole genesis of this pendant box that's actually up in the ceiling that's allowing you to use the conduit coming down, it says, well, when you are supported by only one conduit, it says the threaded joint shall be prevented from loosening by the use of set screws or other effective means. Or the luminaire at any point shall be at least 8 feet above grade or standing area. So above grade or standing area, maybe you have a platform or whatnot, that's still a standing area, and at least 3 feet measured horizontally to the 8-foot elevation from windows, doors, porches, fire escapes, or similar locations. Okay? And then it goes on to say the luminaire supported by a single conduit shall not exceed 12 inches in any horizontal direction from the point of conduit entry. Okay? So it can't go left or right. It comes straight down, if you will, from the application. All right? It can't deviate more than 12 inches horizontally from the point where the conduit enters. Okay? So let's kind of break that down. In other words, you've got this 12 inches left or right from the point where it enters in, and it can't deviate from that. All right? Probably not going to happen, but we're just going to keep. So let's kind of break each one of those down so people get confused, because I just read it to you. Let's break it. Okay, so let's tackle the first one. Well, let's tackle the most low-hanging fruit. Let's move backwards. The 12 inches, horizontal. It says the luminaire supported by the single conduit shall not exceed 12 inches in any horizontal direction from the point of entry. So take a luminaire, draw a line down the center where the conduit comes right into the luminaire. That luminaire itself cannot exceed 12 inches horizontally from any point of the conduit entry. So to the left of it, to the right of it, you have to make sure that luminaire is not more than 12 inches to the left or to the right of the center point. Easiest thing to probably say is to make sure that the total distance across that luminaire is not more than 24 inches. So it's not 24 inches wide from the center point. because that is basically limiting you the size of that luminaire as far as left and right. So that's width of it. Okay, so that's a limiting factor on the luminaire size. So that's what the last paragraph states there in that rule. All right, so that's in 314.23H2. That is the last paragraph. So now let's move up and deal with the 3 foot and 8 foot, what we're talking about there. All right, since we know that these luminaires, in this case, it can't be closer than 8 foot from the grade or a standing area that's serving as a grade, platform or whatever it is, that we have to be at least 8 feet up. So all this is saying is that up to that 8 feet high, that it has to be, the luminaires have to be no less than 3 feet away horizontally from things like windows, doors, porches, fire escapes, whatever, because people could reach them. They could come in contact with it. So that's just kind of allowing for separation. So it's kind of painting this picture. An imaginary box, if you go out 3 feet and up 8 feet, then that's basically your luminaire has to stay out of that zone to the right at the 8 foot mark and up, away from any doors, windows, porches, fire escapes, or what have you. That's the concept of what we're trying to achieve here. Okay. All right, so that pretty much covers its application when it comes to that. Now, there's only reason that I can think of about this now. This is a very common practice for like in industrial occupancies where they're hanging those big HID lights, those luminaires, and they hang them from a conduit stem. All right. Now, if they're 18 inches, it's rigid. Okay, but the rule really was focusing on the brake force. So once they get beyond 18 inches, if they move back and forth, if you didn't have that flexibility at the actual where it hangs to the box up in the ceiling, then if you didn't have that flexibility, then you have if it moves back and forth, then it could put stress on those threads. And eventually those threads could weaken, expand, break down, and then the luminaire would fall. Okay? So we're trying to preclude that from happening. And so again, this allows you to have that kind of flexing, if you will, at the very top. It's a good rule, okay? So that's where we're at for that one. All right, so let's see where we're at in time. We're at 1 hour and 11 minutes, so I'm going to end this episode. So what we did was we really did go over a lot of stuff here. We went over supporting boxes, raceways, surface extensions, and supports of boxes and all the nuances that are involved in that. From here, we'll move on to boxes and depth of boxes and talk about the minimum box depth and all that kind of stuff. And we'll talk about that. So that'll be part 5, I guess, in the episode. Again, visit our website, masterthenec.com, and you can get links to our YouTube, podcast, whatever from there, if you will. And listen to all the video, watch the videos and listen to the podcasts and share them with other people. I'm sorry they go long. I am long-winded. I understand that. I can't change it. There's no sense in being nasty about it. If you don't like how I do this, then don't listen. That's a simple approach. Just don't listen. If you like what I bring you, then listen. If you learn something from it, great. Share it with somebody. If you have any comments or you want advice or you need some help, email me at info at masterthenec.com or info at electricalcodeacademy.com. I'll be more than happy to answer your questions. I answer thousands and thousands of questions a year, each week, from people all over the country. I love answering your questions. Many people charge you an arm and a leg to do that. I don't. I like helping you. That's my way of giving back to the industry and helping people pass their exams, becoming the best that they can be. If you get an opportunity to support our program in some other way by donating or buying a program or getting part of the CMECP program or giving back to us, it does help us out. We appreciate it because a lot of this stuff takes my time away from family to produce these things because I really want to share something with the industry. Your support is greatly appreciated. Just listening, it really benefits it. So thanks again for listening. God bless, and stay tuned for part 5. Where we'll get into things like the depth of boxes and all those type of things before we move into the big topic, and that is straight pulls, U-pulls, angle pulls, all those type of things for conductors that are 4 gauge and larger. That will be a fun one. But keep listening. We're going to get into a bunch of stuff like covers and plates and all this kind of good stuff. So till next time, stay safe. God bless.
Every day, the future's getting closer. closer. Every day the future's looking bright. Every day is another